Thank you for that introduction. So I saw a good number of hands go up when you were just asked how many people have heard the term PWA, Progressive Web App. That's pretty good. For those of you who don't know, PWA, aka Progressive Web Apps, aka installable browser apps, are installed app experiences that are fundamentally different UX for web developers. So previously, to do things like push notifications, using your app offline, accessing your data from the app offline, or having an instantly loadable user interface was something you could only achieve with a native app. And now, with this technology of progressive web apps, that is no longer the case. Browsers can do these things for you. So this new territory, this new user experience is a superior user experience in a number of ways for your browser experience. And primarily, honestly, because the UI performance improvements that are made possible through progressive web apps. So I'm going to take a second to introduce myself. My name is Hasan. I'm the principal consultant at Aquent Dev 6. So Aquent Dev 6, if you don't know, is a front-end focused training and development consulting company. We are 99% JavaScript, so front-end, back-end, all JavaScript. We build VoIP and chat apps for the telecom industry. We build real-time telemetry and diagnostics apps in the browser for the automotive industry. We built a modern search UI for a company called Terranet, which actually manages Ontario's electronic land registry records. And we built B2B e-commerce portals for retail giants like Adidas. So we're not really industry specialists, we're web technology specialists that work across a number of industries, primarily using JavaScript for all of our clients. On top of that, I also I co-lead Developer Circles Toronto. So Developer Circles Toronto is a meetup group that operates in Toronto. We also have a Facebook group, and we share content online and have meetups in person, live stream. We've got about 1,600 members in the community. We launched in 2017. Anything for guidance, training, networking, learning about the latest tech from the Facebook platform, or just stuff that's going on in Toronto. You're all welcome to join and participate. And I also wanted to say that on April 6th at DevHub, Lighthouse Labs in Toronto, we are hosting a hackathon all about Oculus and VR. So there's a URL there. I'll put it up on another slide again as well. You can take a picture, take a look. If you're interested in VR and the Oculus platform, April 6th, DevHub, that's where you have to be. So that's kind of the plug for that. Let's get back on topic though. So this new user experience that's available with progressive web apps. I'm kind of claiming if you're building a progressive web app and you're not worried about performance, you probably don't have a reason to care about progressive web apps. That's kind of a strong claim. I know there are other reasons to build a progressive web app. Maybe you just want a fancy icon on the home screen of your own and you leave it at that. Maybe you want to get around the App Store or the Play Store and do something that they don't allow you to do, or you don't want to pay that royalty that they take. But honestly, those aren't really the best reasons. I'm claiming that the best reason to build a progressive web app is to take advantage of the performance experience that you can provide. So you've all seen this screen, I'm sure. Your typical web application is going to blank screen if you load it offline. Most web apps are written in a way where the UI navigates to a page, waits on some data to come back from a network request, and then we render the UI because that was part of the data that came with that request, and then we render the actual data. And all of that has to work for you to do anything, to even start. It doesn't have to be that way anymore. With progressive web apps, we can actually have offline experiences. We can actually bring the user interface part of our web application or our web experience available locally on the device that's accessing this thing without dependency on the network, without dependency on pulling something from a remote source. So you can load up a UI, you can load up your data, and provide some interaction with the user without being dependent on an internet connection. We have reliably, instantly loadable user interfaces here. Now, web developers are already kind of trained to decouple content and presentation. This is something that you're kind of encouraged to do as you start learning about web development all the time. There's layout code, and then there's content code. So you kind of already have this idea in your mind. And if you've been building single-page app, framework-based apps, you may be using Angular, React, Vue, whatever it is, these concepts actually kind of extend even into these frameworks. We have the concept of high-order components, smart components, dumb components, and we can separate content and presentation. Progressive web apps are basically the next step. Not only are we separating in the code what is content and what is presentation stuff, we're actually able to separate this stuff over the network. I can take my presentation layer and install it on the client device now from a browser app. So this is, the start of the concept of offline experiences for your browser application. This wasn't previously possible. Traditionally, this was a core user experience differentiator between native and browser apps, but that's not the case anymore. So what we're doing here is we're actually taking a piece of our web app code and making sure it runs independently of the network. Independent of pulling in some data, we can have our layout code, our images, our logos, our navigation, all of that stuff loaded locally, and make our application dependent. All the other network-dependent stuff can come as and when you need it. This is already a big performance win because you can bring some stuff to the page if you've thought about it and set it up that way. You can actually have your application usable entirely without an internet connection. All these questions about network latency affecting your user experience, if you've architected and planned for that from the start, you could say goodbye to that problem until you have to do a cloud sync. But in a lot of cases, a lot of web applications actually can be architected in a way where they can work with local data, allow the user to interact with that local data, and maybe even save it and persist it and go back and forth without any internet connection at all. So this kind of architecture is kind of described in something called the app shell model. And you can go deep on the app shell model to look at what does it mean to build that presentation layer as an independently installable piece of software that does not have to be coupled to loading data from a server or loading anything from the network. So I built one. Now this is a simple progressive web app experience. It's basically as simple as it could get. I built this tutorial example just to kind of get my fingers dirty with progressive web apps. But I mean, this whole little clip here, it shows what it's like to find a browser application. With Chrome 73, we can actually install it directly through the context menu and natively install a application on the end user device in like 5 seconds? If you're a native app developer, the bar has been raised. I did not have to download a 300 megabyte binary and wait for the installer. In 5 seconds, I found out about this thing, and I have an experience available locally. I've got a launcher icon. I've got my own window. I appear on the nav bar for the operating system. I mean, could it have been easier than that? Probably not. We have a standalone browser window without the Chrome, without the URL bar. If I actually serve this through HTTPS and not through HTTP localhost, you wouldn't see that localhost 8080 giving away that I'm actually running a browser application. But honestly, it's that easy. It's that easy to start with this huge performance win right out of the bat. My entire UI stuff is no longer a network request that prevents my users from starting to interact with my experience. Doing that much is honestly pretty easy. That little tutorial app, okay, it's not big. It's like one of the tiniest HTML files. And to set this up, all you really need to do is create a manifest file. My manifest file's obviously got a place where my icons for my apps are. This is something you typically wouldn't have to worry about if for a browser app. But if we actually intend for this application to be installed on the device, through the home screen and through the nav bar, wherever it is, we have to provide this stuff. So, it's probably the first thing you were thinking about. So the answer to that is yes, you have to specify those icons, put those images in there. And then there's a number of other things. I mean, the most interesting one here is the property called display. We can set it to standalone, and that's how I'm telling the browser that when this application gets installed as a progressive web app experience, I want my own window on the operating system. I don't want to be a tab in a browser. And I don't want a URL bar, any of that stuff. Okay, so now that we've got that out of the way, we've got our UI installed on the client side without the network. I don't need to make a network request to fetch my UI before fetching any data. Let's start thinking about this a little bit more deeply. When we deploy web applications, especially with the trend of responsive design, we've increasingly been able to build web applications that can serve mobile and desktop users. From a design perspective, we've thought a lot about this in the last 10 years. We have a bunch of frameworks and tools and libraries and best practices that kind of teach you how to lay out the content in your site or your application so that it'll serve a mobile device and it'll serve a desktop device or a tablet or whatever it is. But now, when we start kind of breaking the boundary and getting outside of the browser, and we're offering the ability to install this experience on a device and almost masquerade as a native app, even though we're not really a native app, you have to actually start thinking about things a little bit differently. So, the whole mobile and desktop story on just a native app, there's a lot to think about there. People build native apps for desktops differently than they build native apps for mobile. So, doing things like supporting keyboard shortcuts, managing links going in and out of your application, all that stuff we have to think about. But from a performance perspective, that's also something interesting to think about. I can download a version of Photoshop for my iOS device or for my Mac OS computer, and they might be both native apps. But just because I can serve the same experience for both of them doesn't mean it's actually a good idea. The native app developers for both teams have actually looked at and decided which feature sets make sense for that end user. You have to actually start thinking about that when you build a mobile app. Just because I can build a web application and deploy it to serve mobile and desktop users doesn't mean I'm going to get good performance if I try to ship Photoshop or Premiere, something that does heavy video editing or heavy network consumption. Just because I can install it and make it look like a native mobile app through progressive web apps doesn't mean it's a good idea. So this concept of responsiveness, yeah, there's a design side of things, but there's also a resource capability side of things. Mobile devices are still significantly slower and don't consume as much bandwidth for a number of reasons. You don't want to burn people's data plans and things of that nature. So all of these things have performance impacts. Another really interesting thing that progressive web apps can do here that actually isn't possible with alternatives is this bundle that we install on the client side. We can actually control how it gets updated in more fine detail than a native app. So your native applications, when you distribute them, you actually have to install binaries called installers, either DMG files for Mac or MSI or EXE files for Windows. And those are entire native application bundles, and they can go in size from, I don't know, a megabyte to 100 megabytes, 500 megabytes, a gig sometimes. And that's just a bundle that contains everything that your app has, including some trivial things like icons and resource files. When you have a native app and you update a single resource that gets bundled in that binary, you have to push out that entire binary again to your end user for them to get the update. So if I change my logo, like Slack, all the end users of Slack have to download the new binary. We're going to consume all that network bandwidth all over again. The only delta in between the old Slack and the new Slack may have been the logo. Progressive web apps allow us to customize how we actually update our locally available resources so that I can actually just push that 2 megabyte upload, that new icon, and leave all the other stuff behind. So this is also another feature of progressive web apps from kind of update performance perspective. So the way we do that is through the use of something called service workers. So service workers are a special type of web worker. How many people here actually have heard the term web worker? A good amount. I mean, that makes sense. We're talking about web performance, right? So if you already know about web workers, you basically can run JavaScript code in another browser thread outside of your main application UI thread. And here you can do computations, you can actually request resources from the network if you need to. You can do a whole bunch of things here other than update your main UI. That's only controlled by your UI thread. So a service worker is a type of web worker specifically for progressive web apps that allows us to control what we are installing. So we can say this index file, that's kind of the starting point for my app shell. These images, I also want them to be installed locally. And we can actually build as complicated or as simple a service worker as we want. I could create a service worker that does nothing other than install an icon on the end user device and nothing else. So your progressive web app in that case is really just a glorified bookmark because everything else behaves just like a browser app. But we also have the ability to actually customize some pretty intricate behavior of our application. We can actually build caches. I can cache resources locally, and every time a fetch event goes out of my application, I actually have the chance to check if my cache has that resource, return it, or go and fetch it if it's not there. That's what I'm doing in this web worker. The next thing I could do here is I could actually upgrade this cache to actually grow. So the next time I have a cache miss and I fetch a resource that wasn't in my cache, I can actually put it in the cache. And then the second time that resource gets requested, I'm not going to go over to the network again. So the functionality that we want to build in our progressive web apps is up to us. We can go really simple, or we can go quite complex. So there's more to that than just fetching resources and caching stuff. We can actually update locally available data as well. So just like we can update an icon if I've changed my icon, we can also update data. So if I have a document that's synced with the cloud and I wasn't even running my application, but some change happened. Maybe this is like a collaborative file sharing system, and me and user B are working on a document that gets synced in the cloud. So my progressive web app can keep track of all the changes that I make on my device as user A. And I can close the application. I can be offline. User B could actually use this, one way or another through the application or some other way, update that document. And the next time I load up my application, it's not a guaranteed thing that I have to wait for the update to come around. It's actually possible with service workers to execute code when your application is not even running in the foreground. So service workers can actually do background cloud syncs, for example. The next time your user loads up your application and document, we can actually check if that's up to date. And if it's already up to date, we don't even need to do a full resource download. So we can cache files or whatever it is our application is doing. We can use push notifications. Our notifications don't necessarily need to display anything to the user. Those push notifications could actually be a trigger for a service worker to go ahead and update some data in the background for the user. And next time they come back, we're not waiting on a network resource request to actually provide the most updated data to the end user. So hopefully I've made the case to you guys that if you're building a progressive web app, you certainly should optimize a whole bunch of different performance features of this. There's a whole bunch of tools out there. We've already started talking about them. Shout out to Patrick for web page test. Of course, I have to mention that again. But there's a whole bunch of them, and you don't have to use one. You can use whatever you're comfortable with. Some people use the Gecko profiler from Firefox. You can use DevTools, which is what I do. I'll describe kind of what the experience is like when you start optimizing these things. The point that I wanted to make before was really that you should certainly take performance seriously when you're building a progressive web app. Once you actually understand that, other than installing a service worker to actually put your application shell on the client-side device, The rest of the performance issues for your progressive web app are really the same performance issues as your regular browser app. This is still a browser app at the end of the day. So I'm going to quickly review what that looks like. And maybe this might be the first thing that surprises you, actually. Many of you may have heard of the Lighthouse tool. It performs audits on your applications. So you can get a you can get a detailed report, a breakdown of all the performance characteristics of your application. Is it actually complying with industry-known best practices for high performance? Unfortunately, on Chrome 73, if I actually took my browser app, my progressive web app, tried to run the Lighthouse audit on it, that doesn't actually work yet. That kind of surprised me, but it's probably going to be fixed in the future. For now, Lighthouse can only run audits on applications that are actually in a browser tab. So if you try to do this, you're going to get that error message and be a bit surprised. Not a big deal. Okay, so I went back to my application in browser form, and now I'm going to run an audit. So again, for those of you who don't know, I'm just going to kind of quickly show you what that looks like. Running an audit, you get a pop-up here that kind of shows you what kind of audits you can run. Lighthouse allows you to choose between a desktop device or a mobile device that'll actually simulate the scenario you check for. You can actually get it to check network conditions, so you can tell it to simulate, you can tell it not to throttle at all and just use the fastest internet you have. You can tell it to simulate 2G network conditions, you can tell it to simulate 3G network conditions, and you can run a whole bunch of other audits. So I audited my super simple app and I got 100. Well, I'm amazing, right? Not really, because there's nothing in this application. If I didn't get 100, that would be a huge problem. Let's look at something a little bit more interesting. One of the most popular, most well-known progressive web apps that's in production right now is the mobile.twitter.com progressive web app. Twitter actually used to maintain native desktop apps. They used to actually distribute a binary for iOS, for Android, and for desktops. And then they stopped. It was too much work, probably. What they allow you to do, though, if you want a desktop experience for Twitter, is you can go to mobile.twitter.com on your desktop device and install that as a progressive web app. And you get that Twitter icon on your home screen. It appears in your nav bar. And you can load the UI offline. So this is an example of what happens when you actually run a Lighthouse audit on mobile.twitter.com. So this mobile.twitter.com is a fully implemented progressive web app. And if I run a performance audit on this thing, I think I set it to mobile, just for variety's sake. You can actually see when the audit runs, the browser re-renders this in mobile layout. I think I left it as desktop, actually. But basically, it's running this test, it's taking snapshots, and it's going to provide us some metrics, some report on everything that we're doing after this test is completed. So it takes a bit longer. Twitter's got a lot more going on than my simple test progressive web app. But I get some results at the end. Ended up running at 68. I'll give Twitter a break. They have a lot of stuff going on. Maybe my network conditions weren't so great when I actually ran that test. Sometimes it runs a lot better. But it's pretty cool because that audit, I think, is actually a lot easier to look at than just opening up the Chrome to performance tools, especially if you're not used to that. It's kind of really confusing what's going on. What are you actually looking at? You get that list of things. You get an overall score. And interestingly, there's also this trace feature that actually shows you the full performance trace from the Performance tab of Chrome. And you can actually hover over different time slots in that 5,000 milliseconds, so 5-second time window when the test ran. We can go millisecond by millisecond, see which JavaScript was requested, which CSS was requested, which images were requested, how long did they take to load, how long did they take to execute, what did my application look like after that finished. So we can actually drag along the timeline here and see, as we move further along, more and more UI is being updated. And I want to talk for a second really quickly about what you're actually seeing there, because these terms actually all appear on the Lighthouse audit. And the first time I saw it, I was super confused. I mean, first contentful paint. Contentful is a made-up word. That's not a real word. But it makes sense for this context, I guess. So let me just quickly describe what they're trying to tell you when you look at your trace output. First contentful paint is one of the milestones in the application startup process. This is measuring the time between navigating to your application and the time when the browser renders the first bit of content on the DOM. So again, you'll notice as I describe these things, maybe you don't think that these milestones are that important. These milestones are based off of a slide I mentioned earlier, a model called Rail. I'll talk a little bit about Rail. But basically, these milestones are referenced heavily in the Rail performance modeling model. If you disagree, you can go look at other models. Maybe you don't want to do Rail, but let's start with this. So contentful paint, when we navigate to our application and then render some stuff, doesn't matter what the stuff is, by the way. Chrome just says the second any stuff, any DOM is on the page, okay, you've hit the first contentful paint milestone. Time to interactive, so it's basically trying to measure how long it takes for your application to actually be interactive. And interactive is defined as, we have some useful content on the page, useful being contentful really, and some event handlers are actually registered on the page. So if you want to be able to track, you want to be able to respond to button clicks, input selection, typing events, all of those are interactions. And that's what time to interactive is. So we're basically trying to make sure that we know when you can actually interact with the page. First, meaningful paint. Again, this is one of those metrics. What does it really mean to say a meaningful paint? Basically, what Chrome is calling the first meaningful paint is when the biggest above-the-fold layout change has happened. They're kind of using that as an indicator for most cases. Your content is actually meaningful at this point, according to Chrome. First CPU idle. So that one's interesting. So for those of you who are really comfortable and know the kind of the low-level details of how JavaScript works, you'll know that it's a single-threaded, event-driven. It's an event loop. And the idea behind measuring first CPU idle, again, I'm going to describe this when I walk through the Rail idea. But the idea is that we want to actually maximize idle time, JavaScript's idle state, so that you maximize the amount of time the JavaScript event loop spends in the idle state, so that our application is able to respond to user inputs. Again, I find it a bit confusing that Chrome throws this stuff up in front of you without, Rail is actually a subjective model, and most people don't know what it is. So I'll talk about Rail, and then you'll kind of look at this stuff, and if you subscribe to the idea that Rail is the right way to model or measure your performance, then this stuff will be useful to you. And estimated input latency. So estimated input latency is basically we're trying to measure how long it takes for your application to respond to user input. Again, when we talk about Rail, we'll understand what we're actually trying to achieve here with estimated input latency. But the general concept that's kind of driving the definition of all of these milestones is that we're trying to measure the kind of the key performance points where we can say that our application is responding to user input and rendering some UI as fast as possible. That's basically the idea. All of these things are milestones in that, and having metrics to actually measure all of those things is what we're starting with Lighthouse. Again, this is a big world, I'm sure you all know, but we'll just stick to Rail for now. So Rail is an acronym. The first part of it stands for response. And it might be misleading. We're not talking about response time from a network. We're talking about responding to the user with Rail. The idea is we want to be able to complete whatever UI transition we were going to make based on user input within 100 milliseconds. That's just a statistic that's based on a whole bunch of human-computer interaction studies. the idea is that based on empirical studies, human beings can start to notice when something is responding in later than 100 milliseconds. Might be subjective, some people maybe more, maybe less, but we have to start somewhere. So we're going to use this 100 milliseconds benchmark as kind of a goal. The idea is based on all the research that the HCI field has done. If we can respond to user inputs, render some new updates within 100 milliseconds, our users are going to feel that the application is responsive. It's all naturally flowing. There aren't these unnatural breaks. So this 100 milliseconds is actually a budget for the entire process, from recognizing that the user has done something, knowing what to do with that, actually doing the thing, and then rendering the new updated state. You have 100 milliseconds to do that. That doesn't mean that you have to actually get what they, you don't have to actually say, okay, this button is supposed to render me a report in 100 milliseconds. No, that's not what we're saying, because that might be impossible in a lot of places. But if something might take longer than 100 milliseconds to do, we at least need to be able to, within 100 milliseconds, acknowledge to the user that we got your input and we've started a process, and maybe if we know that this is taking a while, we'll start to throw up a spinner or some kind of message to the user. That's kind of a perception issue. The reason we have 50 milliseconds, again, this goes back to kind of the way JavaScript works with idle time. Because we are single-threaded and we're queuing up all of the events that are actually coming, we're queuing up all of the inputs that our page is supposed to respond to. If we want to respond overall within 100 milliseconds for every single input, we're not guaranteed to be able to respond within 100 milliseconds in that frame if there was some other task that was running before we started the input processing code, finish that execution. We might actually end up going into the next frame by the time we finish processing that stuff. So to be safe, if you can actually complete the user input processing within 50 milliseconds, that remaining 50 milliseconds is guaranteed to happen at render update time. So just that 50 milliseconds gives the browser the ability to do other stuff while you're processing your input, because JavaScript may switch to other tasks based on what else is going on your page. The other two letters in Rail, animation and idle. So there's two goals here. Animation means that we want to maintain 60 frames per second. That's basically our goal here. If it drops below 60 frames per second, our users can notice that these animations are a bit choppy. That gives you about 10 milliseconds to produce a frame. This is a big topic in itself. I'm not really going to go into detail on all the things you have to do to get your animations to always produce every frame in 10 milliseconds. But we got to think about scrolling, entrances, exits, drag and drop events, all that stuff that triggers animations typically in our web applications. When we want to optimize them, there's a number of things that we could be doing. It really depends on the animation. What are you actually doing to the layout? What code are you running? But there are some basic things. So if you really want to learn more about how to execute, how to write highly performant animations from a JavaScript level, definitely take a look at Google's Web Fundamentals rendering section. And idle time, again, this is also a JavaScript low-level kind of feature. Basically, to maximize idle time, the idea is if our page is idling, not responding to, not spending cycles responding to user inputs, the next input that comes in will have the most amount of time, most likelihood of getting that input processed within 50 milliseconds. If there's a lot of other stuff going on, if we're serializing JSON or parsing something that came back from another asynchronous network request, or loading an image, or all these other things that could be going on our page, that eats into our idle time. If during that exact moment when a file was being opened up from somewhere, I started a user input, I'm going to have to wait for JavaScript to either finish that task or context switch back to my task. Largely a JavaScript issue, but I refer you to that link to find out more. And then the loading side of things. So this is the tricky one, in my opinion, because the goalposts are kind of always changing. The overall goal here is that we want to load the whole end user experience in a reasonable amount of time. We all know that if we took like 10 seconds to render a web application on a desktop device, your users are likely to just stop. They'll kill the tab or move away. These goals are always changing, though. I mean, maybe I gave 10 seconds 10 years ago to a desktop browser application, But if somebody just built a desktop browser application now, this year, and gave it to me, and it took 10 seconds, I'm not going to open that thing again. Now my patience is like 1 second for a desktop app experience. Maybe on mobile, I'll wait a little bit more. I realize I don't have as much computing power or network bandwidth on my mobile device. So the fact that this is kind of a subjective thing and varies based on people's behavior and varies based on location makes this a little bit complicated. You have to kind of look at what actually flies in terms of acceptable load time, based on scenario, based on devices, based on where we are. But we have we have some places to start. So the GSM Alliance actually did some studies and found that a good device to use as a benchmark is something like a mid-range Android device with like 3G level speed. And we've kind of, as an industry, agreed that if you can load your whole application within 5 seconds, for that type of device, that's pretty good. That's a decent goal to start with. Might be faster if you've got a very narrow demographic. Maybe I'm only interested in people in this area that has amazing free, fast Wi-Fi or one of those Google fiber towns. But at a high level, we have to start from somewhere. So that's, again, a big topic. There's a lot of things to think about here. But yeah, we're going to think about network latency and speed, hardware, cache eviction. But I mean, one thing I want to really make clear here is that just because this is a complex topic, we shouldn't kind of look at this as like, oh, this is so complicated. I don't have any. There's no actionable item here because I'm not going to go and do a study on my users in the other continent somewhere. Figure out what devices they are and make a plan based on that. No, you don't have to go that crazy. I mean, maybe if you're one of the largest tech companies in the world, you do. But if you're just building your basic web application, you want some good guidelines, there are some basic things we can deal with in terms of loading. So let's look at the most fundamental stuff that we have to load for our web application. We have to load scripts, styles, our HTML, and our images. So scripts and style sheets, there are low-hanging fruit, as Chris this morning is actually saying, compression on the right files. If you're not doing that, that's a huge load time win. Style sheets, another big thing that's going on with style sheets with this whole mobile trend has been it's really easy to put all your media queries that have specific styles for every type of device that your end user, or every type of end user device you're trying to support. So you want mobile specific styles, you got tablet specific styles, you got desktop specific styles. In the future, you're going to have watch specific styles, you're going to have VR headset specific styles. All of a sudden, your single style sheet is like 5 times the size that it used to be. You don't need to load that one gigantic file for everybody. So there are ways to actually solve this problem. You could, in theory, in a very simple way, put the media queries for each device in a separate file and load the one that's relevant to the device that's being served. Simple things like that can help. Images is a really big one. So first of all, do you need all of them? A lot of times they're frivolous use of images. If you can actually go and look at your web application and say, I can get by without those, I can use icons, I can use some font, icon fonts or something like that, depending on the scenario, you might be able to have a huge win just by eliminating entire images from your application. Metadata inside of images, this is a huge culprit for image bloat. Like you can trim like 10% off of some images by stripping the metadata off. So if you have like 30 images on a page, 10% of that for each image, that starts to add up. If you are needlessly sending metadata that is irrelevant for your end users or your use case, definitely stop doing that. The appropriate file formats. So we talked a little bit about how SVG can be cool, but a lot of people use PNGs unnecessarily. Like PNGs are not great for your avatar. A lot of applications will have a PNG for an avatar. That's terrible. Use a JPEG instead. You'll notice that the images, if compressed appropriately, could be like half the size of the PNG. So just thinking about things like that, file formats, compression, alternatives to images, these start to really get us a lot closer to our load milestones faster than you would think. And then as you get to that last 80% of optimization, you might have to really start thinking about which devices are supported where, which users are accessing your device, what types of devices they have. But hopefully, that kind of describes what the thinking is behind the Rail model and how Lighthouse tool and Chrome Dev Tools metrics can be used to build some performant web apps and then progressive web apps, and then also on top of that, install your client-side UI on the device, and all of a sudden your web experience is way more performant than if you just built a traditional browser app. So in summary, if you're building a progressive web app, don't waste the opportunity to address first-class performance. It's time to push the boundaries of web user experience. More and more browsers are shipping that functionality. PWAs are going to land in Safari hopefully this year. Chrome has landed macOS support. It's going to get bigger in 2019 and 2020. As web developers, don't waste the opportunity to really show what the web can do and raise the bar. Thank you.